year virtual meeting. So we're doing it through Microsoft Teams. My name is Mark Wallace. I'm a director in ARUP, looking after infrastructure in the Philippines, and also director of Hong Kong office. So I'm the chairman for today. So James Rickard would usually be here. He's the president, but he's currently in America working on some projects there. So he can't be here with us today, unfortunately. So I'll just quickly run through some sort of background behind the Philippine Tunneling Society, just for those people who are maybe not so familiar. There's a website. You can go there and log in and see some of the information that's available for the Philippine Tunneling Society meetings and so on. So please go and do that. And the contact for that is there as well through that portal. Just as another sort of introduction about the Philippine Tunneling Society, it's a non-stock-based organisation, non-profit organisation, and the office location is through First Balfour, one of the founding companies for the Tunneling Society. It's been formed to promote an understanding of the tunnelling within the Philippines, and basically to try to pull people together, you know, who are thinking about and wanting and interested in tunnelling within the Philippines, and to promote the best practice, organise technical talks such as this, and also site visits, but unfortunately over the past year, because of COVID and so on, not being able to do that, and we want to get back to normal as soon as we can, and hopefully get some site visits towards the end of this year. So that's the plan. Just to remind people about the trustees of the organisation of the Philippine Tunneling Society. So far, James Rickard is the president, Abby is the Abigail is the secretary, Malcolm Lorimer is the treasurer, and then Thomas and Anthony are also organising various parts of the trustee board, as well as events and so on. So in terms of the programme today, is a regular meeting. It's just to go through Microsoft Teams. We have ACCIONA who are going to present. Fernando is going to present on the complex tunnels in a dense urban environment. We still have some slots during the year, so the plan is to have every Friday, or as close to every Friday at the end of each of the months, to have a meeting. There's an AGM planned for the 30th of April. We would love to be able to do some face-to-face, and we'll try and organise a maybe a limited session where people can meet and try to organise a face-to-face with a combined Microsoft Teams for the AGM in April. So that's the plan. You'll see TBCs there, so you know, as the pandemic continues, we'll try to see whether we can do some combined face-to-faces towards the middle or end of the year. And as well, you can see there that there's some presentations that we may need to firm up on as well. So for those presentations, for anybody who's have a burning desire to share some of the information that you have for maybe projects that you've completed, projects you've done, design that you've done, you know, we have a call out for speakers, so please email Philippine Tunneling Society. Abby will then process that, and we'll get in contact with you about how to make a presentation to the society and to the members. So also just a reminder, the corporate sponsors and members, we have corporate sponsorships that are shown here, corporate members that are shown there. They have some privileges in terms of people that can attend the meetings. Generally that's the face-to-face meetings, and we have 12 number individual members as well. And also just to remind people that the membership was waived for 2020. Basically the follow through from the previous year because of COVID, we extended that membership for all those people who had already joined, but this year we're trying to get renewals of memberships so that we can get prepared and ready for continuing this the tunneling community in the Philippines, and try to get the face-to-face meetings organised. So it's just a reminder to renew your your memberships for the year, please, guys, and follow the email to talk to Abby and the rest of the committee about how you want to join and what sponsorship you may want to do. So this is a sort of regular thing that we'll have. We're trying to put together some sort of snippets of tunneling news, so things that are coming up in the market and tunneling in the Philippines. Metro Manila Subway, I think many of you guys will know, is underway. CP 104 tender is already going in very soon, and there is various underground sections, allegedly up to 25 TBMs to be operating in the Manila area on this project. So quite exciting times in terms of a full underground metro system being developed for Metro Manila, which is long overdue, as we know. Makati subway construction has been awarded to China Construction Second Engineering, and that's an 8-kilometre subway line with various stations sort of circle around the Makati area, planned to be operating by 2025. Another one on the horizon, which is sort of developing, is the possible flood protection schemes for Paranaki Spillway. So this is a JICA study. They're looking at different potential alignments, and I think that's going to be pushed forward by DPWH. But that's an interesting one that could help, in terms of controlling the flood water in Laguna Bay, certainly reducing the peak and reducing the period for flooding and high water levels. Dalton Bypass, another one that's up in the Sierra Madre Mountains. So this is to give an alternative routing past the existing road, which is frequently blocked by landslides. So there's various schemes being looked at. I think this is going to go into DED soon, JICA funded, but interesting in that it's still looking at various options of alignment and length of tunnels to provide the final sort of connection. I know that the two ends of the road are already underway in terms of construction, so DPWH are already upgrading some of the connecting roads to this tunnel area. And then there's the Davao City Bypass. So this will be the longest road tunnel, 2.3 kilometres as part of the first segment in Davao. And this has been, I think it's been awarded to Shimizu, Ulticon and Takanaka in October last year. I don't know exactly the current status of that, but it's certainly, that will be the longest road tunnel in the Philippines when it's built, hopefully within the next 3 or 4 years. Also, there's a small tunnel probably in Wawa Dam in terms of the intake structures. So there's a tunneling package being considered for that in terms of the intake, the outlet tunnel and the intake structure. So for today's presentation, we are going to run through it in Microsoft Teams. So in terms of how it's going to work, please put your questions into the sort of comments area. And we will answer the questions after the presentation. And if you can put likes on the questions and you can monitor it as it's going through, please put the likes and we'll try to choose the questions that are most liked to get the speaker to respond. And the PowerPoint will be uploaded to the website after the event with this, also with this presenting the sort of summary at the beginning that I've just presented as well. So today we're really pleased to have Fernando Vara with us. He is the Global Business Development Director for Business Unit for Tunnels and Railways in ACCIONA, so one of the major contractors in the world. He's over 20 years experience and on managing and involved in various major civil engineering projects around the world. And you can see he's been working in Spain, in Australia, Norway, and today he's going to talk more about the follow line from Scandinavia, from Norway, and also talk about some of the other things that he's been doing with ACCIONA and so on. And so this is the sort of overview of the presentation that he's going to give, which is complex tunnels in a dense urban environment. I think you've already been sent this out. The follow line is the thing that he's going to basically concentrate on, but also give some examples from other projects that he's been working on around the world. So without any further ado, I'd like to hand over to Fernando to give us a presentation. Thank you very much.
Okay, thank you, Mark, and good morning, everyone. And I'm pleased to be here today. I really would like to be in Philippines as of today to have a one-to-one meeting with all of you, but unfortunately, due to the COVID, that's not possible. But hopefully, this year we will change this tendency and we will be able to be together. So, Mark has introduced me, so I think I will go straight to the presentation. Give me just 1 second. Wait a moment. I think, can you see it? Mark, can you see the full screen?
Yes, yeah, I can see that. It's good.
Okay, let's run the show. Okay, again, good morning, everyone. Good afternoon, good night, wherever you are. My name is Fernando Vara, and today I will introduce to you some experience we have as ACCIONA around the world in terms of complex tunnels in dense urban environment. The presentation has been structured in 3 different sections. The first one will be a small presentation about ACCIONA to know a little better the company. And the second and third section will be explaining the details about 2 substantial important projects for ACCIONA that are the Quito Metro Line 1 and the Follow Line project. So let's give some kind of figures and sense of what's ACCIONA, what's the company. ACCIONA is a leading global company that is mainly focused on sustainability. We have 3 specialized divisions that are ACCIONA Energy, ACCIONA Infrastructures, and other business, but the full organizational and operational structure are based on 7 types of solution. There are energy, transport, water, social, urban, real estate, or financial. So it's a family-owned company. Our actual chairman, José Manuel Entrecanales, is the 3rd generation of a family Entrecanales that is coming from the 40s something. More than 100 years of history. Our company is listed in the Spain stock market in the IBEX 35, but also I will talk about that later. We have some sustainable recognition in other markets. Global presence, more than 50% of our sales are international market. As I said, we are very focused on energy, infrastructure, and water, but from a sustainable perspective. We are carbon neutral since 2016. You can see a lot of companies are trying to be carbon neutral. We have been, from more than 5 years ago, carbon neutral. Our company actually states around 40,000 employees in more than 40 countries on 5 continents. Here you can see figures about 2019. Actual 2020 are very similar. We have not had a big impact in terms of the COVID, so that's good. Mainly because, as you can see, our sales are around 7 million. Actually, it will be around 6.8 in 2020. 46% are coming from the construction and engineering divisions, and 27% are energy. But if you look at the EBITDA, it makes a lot of sense due to the concept of the energy market. 62% of the EBITDA is coming from energy, and 21% from construction. It's good to say that in 2020 we have got an increase of profit. That in actual status of the world, I think we are very confident that we have been able to deal with the COVID in a good way, and we have very good perspectives for the 21 to 2025 for the market, especially in the energy sector. As I said, sustainability is the hard core of the company. Our owner is very focused on sustainability. He's very active in the Davos and any sustainable indices that we can really provide, that as a company we can change the world and we can provide a response to what the world needs. So ACCIONA is very well aligned with the Sustainable Development Goals. There are 4 goals, as you can see here, that are absolutely aligned with our company, and we are trying to integrate our projects into that goals, no? And also ACCIONA is a member of the leading sustainable index as the one that you can see. So we're a very sustainable company and probably one of the most sustainable company in the world. But also innovation. As you can see, in 2020, the figure was very similar to the one in 2019, around 230 million euros a year just in research and development. We have three innovation centers in Spain, one in Madrid that is related to construction, another one in Pamplona in the north of Spain that is doing analysis of energy, and the third one that is in Barcelona is about water. And that amount of money is really something that we are just trying to get the investment on innovation that has a return to the EBITDA. That is a real something that we invest in the company to get the benefits of the solutions because are getting the project cheaper, the safer, or whatever. So here you can see some ratios that are important. The average in the European community is around 1.5%, and the ratio that is related from the R&D versus sales or EBITDA. Here you can see what are the ratios on Europe, that is 1.5, and our ratio actually in terms of R&D investment versus sales is around 3. So it's more than the double what normally the European community are doing in terms of investment in innovation. ACCIONA around the world, as I said, we're covering more than 40 countries. Our main presence are, especially as you can see, in Spain and Portugal, where we have each of the solutions almost covered. But our market are also strong in Europe, mainly in the Nordics, especially in Norway, and also in Poland. We have a subsidiary company that is Mostostal, that is more than 50% owned by ACCIONA. In terms of Asia and Oceania, especially Philippines, we will talk about that, and also Australia and United Arab Emirates are our key markets there. We are one of the tier 1 players in Australia after the procurement of some projects of land-lease engineering. South America is one of our key markets also. We have more or less covering in some of the countries all of the different potential solutions from energy infrastructure, and also North America, especially in Canada, where we are there since more than 20 years. So what do we do in ACCIONA? As Mark said, we're a big company, one of the main worldwide contractors, and we're specialized in transport solutions that can come from roads and highways. I don't want to extend too much, but you can see some figures around our previous experience, more than 5,000 kilometers of highways, 1,300 kilometers of concessions. That is another part of the company. Also, more than 85 years of experience in bridges and tunnels. You can see more than 600 bridges of all kinds of bridges, and more than 600 kilometers of constructed tunnels. Just to mention, in the last 20 years, we have built more than 500 kilometers of tunnels. 300 kilometers are executed by tunnel boring machines, but 100 are executed by drill and blast, the conventional methodology, and the rest of the 100 are with a cut and cover or road header. So we're covering the whole bunch of potential tunnel solutions. So let's talk about Philippines, because ACCIONA has been really active in the last 5 years in the Philippines. We started in 2016 with the Putatan water treatment plant that is actually finished. Our main contract actually still developing is the Cebu-Cordova Link Expressway viaduct. That is, I will explain and give some figures right now. And also we have been very, very happy that we had recently been awarded 2 projects, the Malolos-Clark Railway project. So those are our 4 actual projects being executed in Philippines. The Putatan water has been actually finished in 2019. The Cebu-Cordova is almost around 68% of advance. So you can see an actual picture. We are just finishing the main tower of the central part of the bridge. And also Malolos-Clark Railway, the project 04 and 02 will start soon this year. So we're very confident that we will, as Mark said, maybe try to compete in the future tunnels that are coming in the Philippines. So the Cebu-Cordova Link Expressway, this is an amazing and outstanding project that I really invite you guys to get into the website, or if you are in the Cebu area, to have a look at that, because this is will be one of the most impressive infrastructures in the region. Here you can see some figures around 3,000 tons of steel, half square meters of total expected amount of earthwork. So it's a massive project. It's actually happening. It's on schedule and it's around 70% executed. So we're very, very happy about this project and how it's performing. So today I will talk about tunnels, complex tunnels in dense urban environment, and there will be two projects, the follow line project and the Quito Metro. But also I would like to mention that ACCIONA is really used to big diameter tunnels. We have TBMs from 2.4 meters so to this one that is our biggest TBM, the Metro M30 TBM that was marked 15.2 meters diameter. It was the biggest TBM of the world at that time, and actually this TBM is going to be executing a tunnel in Poland. We're refurbishing our TBM. We have our own in-house capability of refurbishing TBMs, as I will mention later in Quito. But also the Legacy Way in Australia. I was lucky to be the project director of this project in Brisbane in 2011. And these are two twin tunnels of 12.4 meters diameter. It's a double shield TBM. So we're used to big monsters, to this kind of TBMs, and this is what really the market now is starting to go through. You can see more and more TBMs above 14, 13 meters. And that's what really counts, because when you do a tunnel, it makes sense to do a big section for excavation. Okay, so let's go to tunnels and to special cases and real cases. The Metro Quito. Metro Quito is the most important infrastructure project in the country and probably in South America. Here you can see some data about the client and the project companies. This was a full 100% ACCIONA project. We didn't have any partner. It was full executed by ACCIONA with the direction of the Consorcio Gerencia Metro Quito. That even they have some people that were previously working in Metro Madrid, so they have a lot of knowledge and background about complex tunnels, because as you know, Madrid expansion was very massive during the 19th and the 20s. So this is the project. It's more than around 23 kilometers of tunnel, and almost 20 of the kilometers were executed by 3 EPB TBMs. More than 30 shafts, 28 plus 2. The 2 means because there were 2 shafts previously done in a previous project. 15 stations, 13 plus 2. Again, 2 stations were executed previously. 1 workshop and depots. And the small sections were executed with open trench and diaphragm wall and cut and cover, but the main part of the tunnel was executed with tunnel boring machines. So Quito the tunnel is crossing the whole city. Quito is located in what is called the Quito Basin. No? There is a topographic depression. There is around 3 to 5 kilometers wide, and it's divided into different sub-basins. That is the central north and south. That is divided by the Machangara River and El Panecillo Dome. So the geology, those are earth pressure balance TBM. So you're dealing with complex ground with presence of water. That's why this was the selected tunnel type TBM for the excavation. As you can see, mainly the materials are alluvial deposits and clays, silts, and sandstone, and with water presence. So that's why it was absolutely needed to have a machine that was able to control the water entrance and the stability of the front of the rock. So here you can see at a glance what was the project and the execution. There were 3 TBMs executing the tunnels from one side to the other. The first TBM was started in the Fondo de Saco, and it was doing the final breakthrough in El Arbolito. It executed around 7.7 kilometers, and they have 7, we call arrastres. That is, when you arrive to the station, it's just pushing the TBM through the station. It was not a real excavation, it was tunnel itself. The second TBM was installed in the shaft that was shared with the other TBM, with the TBM2. And this TBM almost did 9.9 kilometers with 5 crossing stations. And the final TBM, the PB3, was started in the same shaft and executing around 3.5 kilometers. So in total, 19 kilometers. It's worth to mention that the TBM itself, it was not a massive TBM, but they were big. They were 9.4 was the excavation diameter. We have precast concrete lining. It was 6+1 segments and with an inner diameter of 8.4 meters. And as is very usual, actually, in the world, the filling of the gut was done with the bi-component grouting. That is the two components that are activated in the TVM at the same time, and makes a phone and fills very well the gap of the over excavation with the outer diameter of the segment. Here you can see the three TVMs, La Guaragua, Luz America, and La Carolina. And I think I mentioned that, but I think our ACCIONA capability in terms of TVM is coming from 1973, when our first TVM, our Robbins TVM, was procured from the company. We have more than 50 years of experience on tunnel boring machines. And we have our own workshops, and what we call the SPO, the Self-Performance Office, is responsible for just doing the maintenance and refurbishment on any TVM that the company has. We have around 5 TVMs owned by the company. In this case, the TVM, the third TVM, was previously work in Metro Madrid. It was called Chotis. You can see it was the TVM number S295. That number means the number of the TVM that was fabricated by Hernek. And in actual days, this TVM became the S1022. So there were almost 800 TVMs built before this TVM. But it doesn't mean that this TVM was not fit for purpose. And I will even show impressive figures about this TVM. So it was fully refurbished in Madrid, in Toledo, close to Madrid, in our workshops. It was commissioned and transferred by boat to Ecuador, and it was performing as good as the two other TVMs that were brand new. Here you can see some data about the TVM. 4-bar maximum working pressure, 5,000 kilovolts amperes in installation power. The nominal torque around 22,000 kilonewton, and it was a passive articulation. It was important for this alignment. 30 double disc cutters. So segments, the precast concrete segments. It was universal type ring. Is a very usual morphology of the concrete segment precast. 45 megapascals. The concrete strength, thickness 32 centimeters, and the length 1.5 meters. So we have two factories, one on the north and another one on the south of the city. And we were able to do a combination of steel bars and metallic fiber for the final configuration of the segments and the design. So the performance of the TVM. Here you will see some figures that probably you are not used to, because these three TVMs were performing in an outstanding way. They achieved the world record in terms of excavation, in terms of weekly, monthly, and daily performance. So the first TVM, La Guaragua, was able to achieve 1,326 meters a month. Here you can see a big stop. And that's something that normally happens when you have such an outstanding performance in the TVM. The stations are not ready for excavation. So you arrive with the TVM in a so quick way that was maybe not expected in such a with these radius that at the end you need to finish the excavation of the station. So that's why you can see a big gap in terms of production. But as soon as the station was finished, you could see we recovered the same productivity. This is the TVM. There was refurbished, as I said, the one refurbished by ACCIONA. Even it seems that has only done 600 meters a month. That's a lot, and the complexity of the area and the geology in that area was much more complex than the other one. But you can see also arrived to around a monthly average of 246 with a peak of 496. So good performance. But the most outstanding one was the third TVM, that, as you can see, was able to perform and obtain more than 1,491 meters a month. This is a world record for a tunnel of 9 meters EPV TVM. So as you can see, we were very satisfied, and the client was really impressed about our performance, because the quicker is a TVM, the less settlements on surface, the cheapest is for everything, the less potential risk of accidents. So it's the best way to do a tunnel, is the quicker, the best, as soon as there is no settlements on surface and everything is controlled. So here you can see some pictures about the project. This is the tunnel configuration, very good quality of as you can see, segment alignment and construction. There are no gaps, and very nice dry tunnel. This is the final picture of the tunnel with the two parallel tracks installed. Also to mention that this is a dense urban environment, means that we were crossing the city of Quito. Quito is one of the most dense South American cities. And also they have historical buildings. Here you can see the cathedral in the Plaza San Francisco, where we need to build one of the stations. So this was a massive exercise just to take out one by one each of the paving stones that was, as you can see on the right-hand side picture, each of the stones were marked with a number, and we need to take it all out and put that again. So there was a massive operation from an archaeological perspective. The full final configuration of the square of the San Francisco square was amazing. There was a lot of people happy about the final shape with the new station integrated in this such a complex environment. Here you can see some pictures about when the construction of the tunnels on the stations with a massive lower slab level for the TVM passing through was built, and some works in the TVM passage cradle when the TVM was just crossing after the breakthrough. And here's the final pictures of some of the stations, very nice and modern. Just to mention that this is the first metro ever in Quito. So the government and the client is doing some kind of training for people to understand what is a metro, because they are scared about going underground. You can give you the sense on how with this kind of project you can change the configuration of the city and the perception of the infrastructure into the population. Also to mention that there is a track works, and there was a big depot for all the trains, and more than 6,000 meters of total track length was installed by ACCIONA. Finally, to mention some social impact due to the nature of this project. As I said, it was the first metro in Quito. The project contributes around 1 billion euros of the GDP of Ecuador, and is very well aligned. More than 42% of the measures contribute to the Sustainable Development Goals. So we're very satisfied about these figures, but also for the environment and archaeological monitoring. Here you can see the figures about how many trees were transplanted, the reduced water, the planted with native species, and also the archaeological monitoring is a very important city in terms of archaeology, and we were very conscious about that. And there is no impact in terms of the project delay due to finding anything, but at the same time maintaining all the archaeology history of the city. So I will share with you a video of the project. So as you can see, a lot of breakthrough and a lot of very nice video shots about how complex the tunnel was in a dense urban environment. So the second project, the follow line project, this is one of the projects I was lucky to be the project director. So it's one of my kids. I have spent more than 5 years in Norway through this project. So first, to understand where is the follow line project, is in Oslo. Oslo is the capital of Norway, in the north of Europe. It's a very north country, so it's very cold. So as I will mention, there will be a lot of challenges. Temperatures. It's a 20-kilometer green tunnel that will connect the main city with is Oslo the capital with Ski, that is a population at the south. This will be the natural way of just developing the new high-speed trains to the south and connecting that to Sweden. So there were 4 projects. The first one was, and the main one was our EPC, the number 3. There was the main tunnels, and there were other small connections with the station, another one with the Ski, and drill and blast works in the north. Here's the client is Bane NOR, is the Norwegian Railway Administration, and the joint venture, the ACCIONA Gela joint venture. Our partner was Gela. ACCIONA was the lead on the works, and this is the configuration of the design team. ACCIONA Engineering, that is our in-house design firm, was the key design member, was the lead, and we have subcontractors Meidel and Covey, but also we have some local subcontractors, Gruppen and PERD. It was our first project in Norway. We understood very clear that we need to have some local flavor, and one of the key Norwegian companies were working with us. So the scope of the works: 4 double shield hard rock TBMs, fully designed for dealing with the hard rock. There is extremely hard rock, more than 35 megapascals of strength. So you need to have a TBM fit for purpose. If not, it was impossible to excavate. More than 37,000 meters of tunnels. And in the complexity configuration that the 4 TBMs were starting in the same location in a central point, and the 4 TBMs were executing the tunnels, 2 to the south, 2 to the north. This creates a complex logistic configuration of the installations that I will go through right now. 40 cross passages. It was not only TBM. You need to connect the 2 tunnels with natural drill and blasting, and here you can see some pictures about that works. 9 million tons of rock. This is a lot of material. We were lucky because the client has prepared an area close to the site that we were able to send and to transport all the material from the conveyor belts from the TBM to the site with no transport outside of the facility. So that was a very good from the sustainability perspective, and we were able to manage that in a good way. More than 140,000 concrete segments. This was one of the biggest ever precast factory in the world. We had 3 precast factories at the same time. But this was not only a tunnel, because you need to do the fit out also on the railway systems. It was a turnkey project, and we are actually finishing the railway works and starting with the railway system works. With a project of this scale, you can see that plenty of people was needed, and more than 1,200 workers were at the peak with more than 25 nationalities. So the language was a challenge, where we were able to integrate the full team with a good multicultural workshop policy that everybody was understanding each other in a good way. So I will share with you what we thought about when we were just tendering the project. This is the presentation we did for the client, who submitted in the tender phase, how we were thinking about developing the full area, because the complexity, as I said, is the 4 TBMs in the same location. So we plan to have like 3 different platforms at 3 different levels. The platform 1 was the one related to the TBM activities, the conveyor belt, the works of the clothing plants. The second platform was about accommodation and the office and the canteen area of the workers living in the camp site. And the third platform was about the precast factory and the segments and the crushing and spoil material area, managing the spoil and the aggregation. It was fully integrated in an area that is a very nice forest. Norway is a very green country, and it was a challenge because there are some neighbors around, and we need to work 24/7 conditions with minus 20 degrees Celsius degrees of temperature in winter. 24/7 we need to work day and night with no dust, with no noise impact on neighbors. So you need to think about how to integrate all these activities in the area in a way that there is no start with the neighbors or any interaction with the productivity. Imagine 14 years at the same time, 1 minute is a lot. So the platform 1 was really about the tunnel. The workshops, the clothing plants, the water treatment plant, the roads for integrating all the transport from the tunnel. I'll explain later how the tunnel was. So it was close to the tunnel in a lower area, so we can avoid the noise, be extended in an area. So The second part was the accommodation area. You can see the main office and our office, the canteen was for the workers, and the barracks. The barracks are the camp. 450 workers were living in a different suite. Don't have a basement for the barn, and the workers were working. The third platform was the precast area, with the material also from oil, and in this area we're planning have more than 2,000 rings for events, so 4 tickets at the same time. It was a lot of time. And 3 integrated gas plant 5 rings at the each. So this is one of the best ever factories in Norway in terms of production panels. But the plant, a very nice work. It has a the area. So this is the reality. This is the tunnel platform 1 section. You can see the blue the offices. The red ones for our facilities, the clients, bring them into the canteen. By far the best Italian and Spanish restaurant ever in Norway. People were very satisfied with the food. We've been to Alaska for 2 years in excavation. The 3 precast factories, all in the same place, up to some planting cranes, and the 3 concrete packing plants integrated cover. Those protected for winter and protected for noise, dust. This is the massive, it was one of the biggest ever cover spoil shed in Norway. It was taken and then loading. Of the weather conditions on the project due to this very good from my point of view configuration and analysis. So the geology of the project, as you can see, is very clear. It's a granitic gneiss, a massive granitic gneiss with a compressive strength of around 300 megapascals, mixed phase conditions, and the maximum overload 150 meters. Groundwater level around 2 meters. Segment design, very standard as the Quito one, universal ring, 6+1, more than 500,000 concrete cubic meters, and the excavation diameter was 9.96, so the ring outer diameter was 955. The multi-service vehicles, standard transport vehicle, but in this case we were just having 2 rings, so it's more than 125 tons of load. That's a massive. And also the radius, because I will explain now the configuration of the tunnel was very complex. Ventilation, it was not the 4 tunnels, it was a lot of drill and blast tunnels connecting each of the caverns for arriving to the area where the caverns of the assembly was. So the ventilation was also a very complex design to maintain all the time any potential fire. Conveyor belts, the 4 conveyor belts were from the 4 tunnels were merged in just 1 conveyor belt that was bringing all the material to the surface to the big shed that I explained to you before. Belts with capacity of 2,000 tons an hour, and with a double capacity. If one was not working, we have a double system in case. Configuration of the tunnel, smaller conveyor belt, 150 tons an hour, but this is a very standard configuration. So the complexity is the logistics. As I mentioned, we arrived to the cavern areas that are 2 square boxes that you can see in the picture. From the surface, we were coming from the tunnel added north, and through the multi-service vehicles, we were bringing the segments or any logistic material to drill and blast tunnels that were executed previously to our award. So when we arrived to the After 1 kilometer of tunnel with 10% slope, a very big slope, we arrived to the central area. You can see here how many pipes were at that time, the complexity of the space with the 4 conveyor belts coming, the ventilation for the area. Then each of the MSBs were going to one or the other tunnel to deliver the segments. Here you can see the caverns. I will explain later the caverns excavation and the TBM assembly. Massive pipes around, complex gantry cranes doing the TBM assembly at the same time. And finally, when the TBMs were receiving the material, typical tunnel section with a conveyor belt, ventilation duct, the MSBs and the pipes, and with a concrete flat surface at the bottom with a precast piece we were fabricating also in the precast factory. And finally, this is the tunnel with all the logistics vehicles were leaving the tunnel. But as you can see, we have then the 2 tunnels conveyor belts merged in just 2 double deck with a massive plenty of pipes. So it was a very narrow. So from the logistical perspective, it was a very complex tunnel. The TBMs, 4 Heranek TBMs. Here you can see the most important thing is about the cutter head design and the weight. This is the heaviest TBM I have ever dealt with, 2,400 tons of TBM, more than 70 cutter rings, 19 inches. And the main bearing, we also increased the size of the main bearing from 6 to 6.6 meters to give a real heavy strength to deal with the Norwegian hard rock. Here you can see the pictures of the 4 TBMs that were in the factory acceptance test in Steinau in Germany on Heranek. It was the TBM provider that, to be honest, has performed very well. We're very satisfied with them. And this was the expected excavation speed, around 12 to 15 meters a day in this massive rock. Important to mention that this is a tunnel with a lot of grouting, and we're in a dense urban environment. The grouting means that you need to do injections ahead of the TBMs to try to avoid the water leakages into the tunnel. So from the TBMs, we have performed 8 kilometers of pre-grouting. This was never done before from a TBM, and at the same time, we have achieved the production as we expected, because when you do these operations from the rig drills, it takes a lot of time. So on the top of what is the normal NACE really configuration of the geology, there were a lot of vertical weakness zones. That was the potential risk areas for water ingress. That's where the client specified different areas with different water ingress, with a small sensitivity to high sensitivity, where we were just mandatory to do pre-grouting in the sensitive, but in the very sensitive also, but in the small sensitive, it was depending on the drills, the core drills we were doing every morning. We're doing a 40-meter probe to check the water ingress. Depending on the liters per minute of water, we were then, related to the different scales, we need to do pre-grouting. Then we need to stop the TBM works and need to do a full round of grouting. That was executed with these 2 drill equipment. Here you can see this is the kind of equipment that you take out from the TBM and the day one, because you never used it. And in this TBM was the opposite. We were just fully working with these 2 drill rigs, but was very well prepared, and we need to even improve the performance due to the complexity of these works, because a lot of pre-grouting was needed. So here you can see there were 38 drill shield positions. Then the drill rigs was doing the 40 drills to do the grouting ahead of the TBM. So grouting was very important, but also that the complexity of the work was the fact that we have 4 TBMs in the same location. And this is a video that shows how complex the assembly of the TBMs was. After the TBM were tested in Germany, it was transported from Germany to Norway by boat and by truck. But the complexity was to assemble 2 TBMs at the same time in a cover, that you can see the cover 30 times 50 meters. Massive caverns, but also very complex logistic work, because 2 TBMs at the same time, you can see the cutter heads, the 2 shields at the same time, and the same in the southern cover. So the complexity of the work was not stopped for us, and we were able to perform the assembly and have the excavation completed. And this was of course in my career I have ever done, to do 4 TBMs assembled at the same time in a cavern. And this is the final bit in terms of the project. How the tunnel was done. You can start with the gas factories, where standard force assembly with molds, the pieces. And for some people it's not even tunnel, but it's a concrete cycle. The real strength is achieved. Then 1.5 ring segments, one and a half ring squat, we have on level. Then with our heavy cranes, we install and transport all the segments to the multi-surface vehicle. So the surface vehicle that makes it 125 tons capacity each. Then this gets into the adits, 1 kilometer, get to the caverns, and then into the tunnel. The MSV arriving to fill the TBM. The segments are then installed and then transferred to the front of the TBM. And as you can see, it's a very narrow operation, but the space then an automatic hydraulic system is up, segments, MSV leaves the TBM, goes back to get another segment, and then each of the segments are transported to the front part of the TBM. This is where the shield is, that is the metallic section for the TBM for the workers for doing the segment assembly. Each segment installed and with 7 segments we build a ring. Every ring is a normal operation. Also, the material comes from the tunnel and the conveyor belts. Massive conveyor belt system, more than 80 kilometers of conveyor belts into the tunnels. All the material comes to the same location. All the material merged into one conveyor belt system. It's the complexity of conveyors. All the conveyor belts bring the material to the surface, and again, in the surface we take the material to the spoil area. So a very sustainable area working 24/7. And this is the TBM production. Not as impressive as the Quito ones, but as you can see, the 4 TBMs were able to do the same performance. That talks about it's not about the TBM, it's about the crew. We have the same good crew with the same TBMs able to do the same. Around maximum 500 meters a month and 30 meters a day. But important to say, this is also doing pre-grouting at the same time, more than 8 kilometers of the 36 kilometers. So the important thing is that you are able to do pre-grouting during the TBM operations with no affection to the daily activities. And this is the way to show it. This was the first 30 pre-grouting rounds. We were not able to do a grouting round in less than 3-4 days, and we realized that it was really having a massive impact. Then much more pre-grouting was expected. Then we realized that we need to improve the system. But at the end, after I would say around 100 rounds, we were able to do everything in less than 1 day, 1 day, 2 days. That's when we achieved the real TBM production with pre-grouting executed from the TBM with no affection. Finally, just to finalize, dense urban environment. Here you can see how dense is Oslo in the last section of the tunnel. So it was important to have community management. We have a very extensive campaign about taking care about the neighbors, to offer alternative accommodation, and to give the right information to the people about the project, because as you can see, the neighbors, they don't want to have problems. The best way to show that we were doing a good job was the survey that the client did. And this is the score we get with very good or good communication about the tunnel. So the people were very satisfied. They were able to see the TBMs where they were performing and where the TBM was close to your property. So they were in advance aware of the potential vibration. And also, it's important, the visitor center. We built a very nice visitor center where we were even able to show 3D models of the TBM, virtual reality, So people were getting really used to this. So finally, the breakthroughs. There is only 2 very happy days in a project: when you sign the contract and when you do the breakthrough. And we have 2 double breakthrough. That is something also that is not very usual, because normally you have one TB and then the other one. And I will show you a video of this magic moment of the 2 breakthroughs in September 2018 and February 2019. And that's it. That's my presentation. Thank you for your attention.
Great, thanks, Fernando. That's really good. 2 great examples of TBMs being used in various places in the world. So I think we have, well, I suppose to have 2 or 3 minutes for questions, but I think, we run through some of the questions that are at the side there. I think the most popular one was have you encountered sinkholes or whatever during tunneling inside a busy city? So I suppose that's whether you may be hitting karst or whether sinkholes have been produced by the TBM or during the excavation. So how have you dealt with them?
There is well, I can say it's funny now, but it was not funny at that time. We were just in the follow line project, just below an existing sewer that was supposed to be built in a nice way, and we were just being only 1 meter below that tunnel. And when we arrived to the section, we were doing very small operations, just half a meter to half a meter to check. And when we were just below the tunnel, then we realized that the tunnel was not executed as expected, and there was no lining, and there was a massive hole. And then we realized it was the opposite. It was at the bottom, and the TBM was going above that tunnel, and then there was no upper lining. So there was a big hole that we can see the tunnel at the bottom, and then the TBM has to go through. So then we realized that we need to do a full lining of a tunnel that was below our tunnel in the chamber of the cutter head that is no more than 1 meter width. So that was a big surprise in terms of having a nice karst in the middle of the tunnel. But not in Quito, but in the follow line, this was one of the cases, yeah.
Yeah, okay. So one of the other questions there was that got high likes was how was the vibration controlled in the Quito tunnel excavation? So how was that? And was there any complaints from the public on the vibration or the noise that coming from the TBM, especially during night operations, I suppose?
Yeah, vibration, as probably you will know, is harder to deal with when you have a rock tunnel more than in a soft ground tunnel. In the soft ground tunnel, the material is getting more or less all the vibration. So in Quito there was not a lot, and also we have a lot of accelerometers and piezometers and checking on surface how the vibration was, and was never to a level that was something that the people could even feel. No, in the follow line was different due to the hard rock. Even we had 150 meters of overburden, the quality of the rock was good, so there was a lot of vibration. So we were just, due to the visitor center, training the people how a vibration could mean. That is like to have a refrigerator at home that is making some noise. In the cases that the people were feeling that they could not sleep, that is some kind of like a flight, maybe in some areas of the night, we offered relocation. We offered accommodation in hotels, and it was well taken. People, they understand that there is a massive project that is well explained, that you take care of them, that you protect what's going to happen, the information is there. So I think the vibration is you cannot control unless you stop during the night, and was not something that the client was decided not to do. Then you need to relocate people, and it's working around the world, and it's a good solution.
Yeah, so I suppose that really comes down to, keeping the public informed, keeping the residents informed of progress, and making sure you manage that actively. It was good.
Absolutely.
Another question which I was going to ask as well is, it's nice to deal with world records, right? So there's a question there. How can you summarize the key features of TBM that, how did you get those outstanding performances in the Quito compared to other projects in the world?
Well, to be honest, if you get a world record, it's because the geology is good. There is no surprise on that. Okay. You cannot do a world record, you have a massive fault zone or a horrible cutter consumption. So in the case Quito, the material was good. But at the same time, if you don't have a TBM fit for purpose or a team that is really experienced and is able to deal with the day-to-day operations in a nice way, the three combinations are making the real deal. So in Quito was these kind of things that happen. We have a very experienced people that are Ecuadorians workers that were working in Metro Madrid in the 19th. So they were local workers that were very well experienced, that were working with ACCIONA in the Metro Madrid. The TBMs are much better year by year. It's not the same at TBM 20 years ago than now. They have a much better capacity of power. Cutter days, 19 inches is better than 17. And the material of the rock was a lot of cutter consumption of scrapers. So it was there, and I think ACCIONA is a good company also, I have to say, so we had the right people. So it's a combination of factors for sure when you achieve this.
Right, okay. So there was another question about how do you deal to some of the challenges encountered during tunneling in a dense city. I think it was, the question came out during the Quito example, and it says storing of, I think it's muck and during the initial drives, right? So how do you manage that early sort of, launching of the TBM, and how you're doing the storage of segments, etc. So what are the key challenges actually at the start of a TBM drive?
When you have a dense urban environment, normally you do the start of the operation of the TBMs in a shaft. So that shafts are normally not located in a place that you would like. In this case, we were lucky, as you have seen in the video, it was close to the airport. So we have an area list that we can store around 400 segments, and to have a diaphragm walls that was allowing us to have two TBMs at the same time installed. But then it comes the utility diversion that has to be done on time. Then you have the risk of having not a lot of cover at the very beginning, so you need to go deep underground and maybe to do some protection on the surface. So the dense urban environment are really coming to have the TBMs ready and scheduled to be bored with no real civil works affecting you. And in this case, I think the client did a very good job in terms of pre-works and early works. That's important to do that in that way, because then the TBM performance, there are plenty of projects around the world that you can see that is very well controlled with this very good tunnel methodology. Everything is controlled. It's more about settlements on surface, to have a very good control on settlements, and to have a nice shaft with logistics that you can do the full operations with no disruption.
Okay, good. I think we've got time we'll probably take another couple more questions. I think some of the questions that are on there, Fernando, maybe you can include them at the end of your presentation so you can answer some of those questions, and then when we post the presentation, you can see that. That would be useful, okay. I think. But I think we'll take another couple more before we end the session. There was one here about waterproofing technology. So I know, about the gaskets and so on. I think the question was maybe about, the segments and the waterproofing that was done maybe at the portals and, at the transition points of different aspects of maybe cross passages, etc. So I think the question was during the follow line sort of presentation. So how do you respond to that?
Yeah, I would say that in terms of gaskets, there is a lot of improvement in the last years about gaskets. Previously, you were just doing the precast segment concrete, and then you were just putting with glue the gasket. That was the normal operations in maybe 10, 15 years ago. Actually, the gasket is casted into the mold and is fully grouted at the same time. So it's very well stick to the segment. That's good. The second thing is that these gaskets are now able, in this case, in the follow line, we have a gasket for more than 18 bars. That is something impressive, because normally we have more than 150 meters of cover. Say, why do you need this? Because the client was very conscious about having tunnel with leakages and then potential ice in the tunnel. So the gaskets were very well prepared, but also with the pre-grouting in front of the TBM, just filling all the potential breaks and water around. And for the opening of the cross passages, we were doing pre-grouting from the tunnel. We were just doing, first of all, we were just opening some water to get the water pressure, doing injections to do a better treatment, and then just with normal excavation lining. So the water, you can deal with it. The only thing you need to spend money doing routing into that and have a nice gasket, a nice design. I think that would be the way.
Yeah. Okay, thanks, Fernando. I think maybe just one more question. I think there was one at the end. There was, what was the ground monitoring program did you employ specifically for some of those projects? So, which has a relatively softer ground condition, such as the, so Quito was soft ground, more Follow Line was hard rock. So, can you just maybe explain some of the ground monitoring that you did for those projects?
For sure. Normally, when you have a rock tunnel, normally there is no settlements. That's the good thing about having rock tunnels, that the rock is good and it's good to excavate and there is no settlements. So in the Follow Line, there was no real any issue about settlements. It was more about vibrations, as I said, and water ingress control. But in Quito, definitely, when you have an EPD, the worst horrible case scenario is to have more material excavated than when that was expected. Then you make a chimney, and then there is a settlement or a hole in the middle of the city. The only way to control this is through the settlement control on surface, to have in the TVN conveyor belts that are weighting the material that gives you exactly what is the theoretical compared to real material that is coming from the conveyor belt. So you are taking out material as expected. Also, to have very good TVN operators that are controlling at any time what are the pressure on the surface of the front of the TVN that you are controlling the material. And on surface, we have intensive campaigns. We have even there is a system that is called INSARC, that is like to have a satellite control of the area 1 year in advance to understand from a 3D perspective what are the levels of the area. Then during the tunnel execution, this was also continuing to be done. So it was a full real-on-time control on settlements on surface. But in an EPD, it's much harder. You need to have a proper analysis of the TVN operators' conditions and also settlement control at any time to control the potential over-excavation.
Great. Okay. All right. Thanks, Fernando. So I think everybody, that's been a great sort of presentation Fernando's given us. I'd like to thank him on behalf of Philippine Tunneling Society for giving us that presentation on those two great projects. Thank you very much for that.
Thank you for inviting me. It was a pleasure to be with you today, and good luck with your Philippines tunneling. But I think Philippines is going to be one of the markets really impressive in tunneling. So good luck with all your work and well done. Yeah, great. We're looking forward to the new metro lines and all that sort of things coming here. So tunneling is definitely one of the hot topics just now in the Philippines for infrastructure. So, all right, great. Thank you, everybody, and thanks for listening. And please visit the website, www.philtunnel.com, and post any questions to the Secretariat. And also, please sign up for your renewals, for memberships, etc. And we hope to see everybody face to face. And remember the AGM in April. All right. Thank you very much, guys. Thank you. Bye.
All right. Thanks. Bye-bye.